Okay, so today we'll be looking at two topics, past climates and the causes of climate change in the past. We'll start by looking at past climates. First, there are a few key terms that you'll need to know. Weather is the short-term day-to-day changes in things such as temperature, wind, and precipitation. Climate is the average of these weather conditions over 30 years. A climatologist is an expert in climate and climate change. Interglacials are known as warmer periods on Earth, and glacials are known as cooler periods on Earth, such as ice ages. Now, we have to find a range of ways to prove that climate has changed over time. If we looked for evidence showing different climatic conditions in the past, we would find things such as fossilized animals and plants which no longer live in a particular region, possibly due to the change in habitat conditions. We could also find landforms such as valleys left by retreating glaciers. You can see many of these in some mountainous regions. You can also find ice sheets, especially in the Antarctic. Scientists often collect and then measure the carbon dioxide concentrations of the air trapped inside the ice sheets. They could then find out about past temperatures using these carbon dioxide concentration levels. We can also find evidence for climate change occurring in recent periods, such as old photographs, drawings, and paintings of a particular landscape or location, written records such as diaries and newspapers. The patterns of dates of regular events such as harvest and species migration. If they seem to have a pattern of changing over time, perhaps this could point out a change in the climate. However, it could be argued that these sources aren't very accurate, as they weren't made to accurately record climate, but they do, however, give us a small idea of how it was like. For example, an account of the Little Ice Age could help us partially understand that person's way of life. We can now look at the causes of climate change in the past. There are three main theories that climatologists have used to explain the natural change of climate. Let's look at the eruption theory. This revolves around the idea that when volcanic eruptions occur, ash and sulfur dioxide gas are released into the atmosphere. If they rise high enough, the stratosphere's high-level winds would carry them further around the Earth. This effectively blocks out the sunlight from reaching the Earth's surface, causing it to cool down. An example of an event caused by a volcanic eruption would be in 1991. Mount Pinatubo's eruption in the Philippines released 17 million tons of sulfur dioxide gas. A more serious eruption would be in 1815. Tambora's eruption in Indonesia had global effects for 5 years, causing 200,000 deaths in Europe due to failing harvest. The second theory is known as the sunspot theory. This theory states if there are more concentrated dark spots in the sun, there would be more solar energy being fired out, hence causing the Earth to be heated up more. This can be proven as in cooler periods such as the Little Ice Age, there were far less sunspot activities than in the medieval warm periods. This theory explains long-term climate change much more effectively than the eruption theory, as it only has a short-term effect. Our last theory is known as the orbital theory, which refers to the Milankovitch cycles. In this theory, it is believed that the Earth's orbit changes in 3 ways over time. These are the 3 main points that you will need to know about this theory. It takes 100,000 years for the Earth's orbit to change from being more circular to being more elliptical and then becoming more circular again. It takes 41,000 years for the Earth's axis to tilt, straighten back up, and tilt again. And it takes 26,000 years for the Earth's axis to wobble, straighten up, and wobble again.